Hi everyone, this is a demo video for Diffusion Explainer, interactive visual learning for Stable Diffusion. Diffusion Explainer is a web-based interactive visualization tool that helps non-experts easily learn about diffusion-based models without any installation, advanced hardware, or coding skills. Diffusion-based image generative models such as Stable Diffusion have captured global attention for their ability to easily create impressive images. For example, this amazing artwork, which recently won an art prize, was surprisingly created by such AI models. However, the popularity of these models has also sparked ethical and social concerns. For example, some artists have accused these models of stealing their artworks and styles. This highlights an urgent need for people from many different fields to understand how generative AI models function and effectively discuss their concerns with AI researchers and developers. However, for people who do not have a background in AI, understanding diffusion-based generative AI models can be challenging for several reasons. First, Stable Diffusion has a complex model structure which consists of neural networks of components and cyclic data flow, and it involves a lot of intricate mathematical operations. Moreover, it can be hard for non-experts to run the model and scrutinize its internals as it requires advanced GPUs and coding skills. To fill this gap, we demonstrate Diffusion Explainer, a web-based interactive visual learning tool that helps non-experts easily learn about modern diffusion-based generative AI models without any installation, advanced computational resources, or coding skills. Now, let me walk you through the key features of Diffusion Explainer using a scenario. Troy, a hypothetical government policymaker, has recently received concerns from artists that their artwork has been exploited by AI models without their consent. To help these artists be compensated for their contributions, he has found tools that aim to attribute AI-generated images to human artists. Before proposing any policies, he needs to understand how and if such attribution works and launches Diffusion Explainer. Troy first is the high-level summary of Stable Diffusion structure and image generation process. Diffusion Explainer visualizes the iterative refinement by presenting an animation of random noise being gradually refined to a high-resolution image and incorporating the timestep controller. By observing the animation and visiting each timestep, Troy understands that the Stable Diffusion's image generation is an iterative process. He then changes the text prompt in the prompt selector to see more interesting images. Observing images generated from different prompts, Troy learns that Stable Diffusion can generate the images depicted in the prompt and even catch the details like style or tone. Troy realizes that there are two controllable hyperparameters, random seed and guidance scale. Troy changes the random seed value from 1 to 2 and 3 and observes a huge change in the generated image in real time. By checking the image at timestep 1, Troy learns that it changes initial random noise and therefore results in 3 different images. He also experiments with different guidance scale values, reducing from 7 to 1 and 0. He finds the generated images hard to interpret and realizes that strong adherence to text prompts is very important in image generation. Troy also tries with the guidance scale value of 20, but it generates an image with exaggerated colors and texture. He learns that the guidance scale value should well balance the adherence to the text prompts and image quality. Troy decides to delve into low-level details of each step of the image generation process. To understand how the text prompt is processed, Troy clicks the text representation generator to see its internal operations that tokenize the prompts and then encode each token into a vector. For more details, he clicks Text Encoder and discovers that the clip encoder, a multimodal encoder that connects text and image, provides image-related information to the text vector representation. Troy proceeds to understand the underlying operations of the image representation refiner and expands it. It visualizes each refinement step that uses the unit neural network to predict noise and then removes it from the image representation. Troy further expands it to learn how the guidance scale controls the adherence of the generated image to the text prompt. He discovers that UNet actually predicts two types of noise, generic and prompt-specific, and computes the weighted sum of them with the weight controlled by the guidance scale to improve adherence. By adjusting the guidance scale value with the slider, he examines the effect. After using Diffusion Explainer, Troy realizes that the existing image analysis methods that do not consider text prompts will be insufficient in determining how an artist's works have been used to create AI-generated images, and thinks that more research is necessary to reliably identify attributions of AI-generated images. So in this demo video, we presented Diffusion Explainer, a web-based interactive visualization tool to help non-experts learn about diffusion-based generative AI models. You can try our tool on your device using the link. Thank you for watching.